the usefulness of having all of these aspects being covered by a single module, from the ability to download data sets or to extract text, as well as also to reformat it and clean it, and to extract the duplicates and filter them and apply different customized ways of filtering and customization and classification, and even apply multilingual tasks and m- perform more of data science related tasks like data blending that basically makes it needed for data preparation. Nemo Curator is also great for synthetic data generation with pre-built pipelines that you can use out of the box for tasks like prompt generation, dialogues generation, entity classification. It's also modular. You can run it and embed it and integrate it with your existing pipelines. And it's open API and OpenAI API is compatible. If you're using the microservice, you can easily integrate it with the custom instruct and reward models from OpenAI. The GPU acceleration comes from another open source framework that we have. It's called Rapids, where basically you can use the traditional data frames from Python and the traditional machine learning from Python using Rapids, and you can accelerate all of that. You can also run graph processing and graph analysis on it, and you can perform fuzzy deduplication, exact deduplication, and you have a lot of different types of cla- classifiers, like whether lexical deduplication, for example, for the exact identical documents or near, kind of like almost similar, or even with semantic deduplication, which is usually focusing on the meaning rather than the exact text. And as you can imagine, the data processing pipeline itself, by itself, it involves a lot of AI, a lot of machine learning, and a lot of classification that requires and relies on a lot of different approaches. And that's why, and that's how we are also able to perform this at scale with efficiency. And the same can also be applied, and even more techniques can be applied for post training if you want to do customizations later on, which actually is a step that you should definitely consider within your generative AI application in order to make sure that your models are always up to date. Nemo Curator also does this for videos and images. You can do that, and basically the data processing can literally decrease from years to days. We have made several optimizations to achieve this. We are now supporting, it's not only for text, but it also supports GPU accelerated video pre-processing and curation to prepare high quality training data sets from visual data. It can scale to hundreds of petabytes of data. The optimizations that we've made are great, from video decoding to encoding on the GPUs, GPU acceleration of all of the models in the pipeline, and avoiding all of the CPU bottlenecks. And we are also capable of automatically providing auto balancing of the stages to achieve peak GPU utilization. The data curation pipelines for videos can do a lot of things. For example, decoding and splitting. You can imagine, for example, decoding long videos and splitting them to semantically shorter clips, transcoding and converting all of the short videos to a consistent format, and also filtering models that can process clips for characteristics, like, for example, aesthetics quality, watermarks, clips with low motion. You have all of these libraries included and capabilities included into Nemo Curator. We are also providing annotation capabilities, which basically can help you to caption videos and images using domain-specific state-of-the-art vision language models to describe the clips in details. And also, we are providing video and text embeddings, which is very, very important. To create embeddings of video clips, and text captions for downstream semantic search and deduplication. This is something that is very, very powerful. You can imagine the amount of use cases that you can have and you can unlock just by using a single module. Developers can quickly gather use case specific, high quality videos to train and test their world models. So, as I said, Nemo Curator can scale to hundreds of petabytes of data. It will lower your total cost of ownership, and you can always rely on us providing you with a state of the art models that are even more optimized rather than their open source counter version. Because with every open source model that you will be using, we strongly recommend that you should optimize the model for inference before you do that. We are also providing the tools for the optimization of the models. I'm going to talk about that later. The results that we are talking about is significant, and it's in magnitude of X. As you can see in here, running an optimized and non-optimized pipeline on a CPU with a certain amounts of data can really take years, as we're talking about. And we can optimize the performance pipelines massively on our infrastructure. And we're also optimizing the throughput of the models. And this is what I was talking about. If you are using the optimized version of the models, you can get an optimized throughput for your embeddings, as well as also for your captioning. Basically, the generation of the models becomes way faster. I'm going to go quickly over the capabilities that we have for model training, just for those who are interested in training large models. Nemo is providing great capabilities when it comes into training LLMs. One of the first things that for those who really love to dig deep into this is tensor and pipeline parallelism. Imagine trying to paint a mural or a picture. You could do it alone, or you could have a team with each person painting a part simultaneously. That's exactly what tensor and pipeline parallelism is about. By dividing the AI's neural network across multiple GPUs, we dramatically reduce the memory needed and enable the training of large scale models. It's like having an art squad of your AI for your AI, making the process faster and more efficient. And next, we delve into the sequence parallelism. This is like a factory assembly line for data processing. So the first one is about the data and the training. This one is about the data and how you are processing the data and preparing the data for the training. This is where each GPU works on a different piece of the puzzle, processing different sections of the data in parallel. And the result, we can work with much larger batches of data during training, pushing the boundaries of what is possible. And then finally is in the activation. We introduce selective and activation recomputation. In the traditional training of LLMs, you would have to save and recompute every single piece of data. It's a very memory intensive task. And with our smart activation checkpointing, we make a trade off. We save only the essential data and smartly compute the rest as needed. It's like having a photographic memory. You remember only what you need and can recall the rest on demand. And this is just a glimpse of what NVIDIA Nemo can do for you if you are interested in training a small or a large language model or a multimodal model. You don't have to start from scratch. I'm working with a lot of ecosystem partners and startups that have built their large models from scratch and they are struggling. You don't have to do that. You can use one of the available foundation models. We have created a lot of foundation models, and we can also leverage others from our partners like Meta and Stability AI. Whenever you get into select or choose a generative AI LLM, I strongly advise you to look at benchmarks. There is a lot of benchmarks. If you are considering reasoning models, if you are considering models for reading and comprehension, or math and world problems, or coding, or multitasking, there is always benchmarks that you should select and choose. Make sure that you define your selection factors, as well as also defining your domain specificity to make sure that you are making the choice of either a foundation model or a final instruct, like final based model that you'll be using in your generative AI application, so you don't have to go and change it. Now, model customization. Foundation models are designed to further be adapted to a wide variety of downstream tasks like question answering, sentiment analysis, image captioning, document summarization, translation, and code generation, as well as also object recognition. Customizing models is very, very important. And in order to do that, there is a lot of different techniques. And we are able to provide you and enable you with all of those different techniques to customize or edit a foundation model and make them your own using domain knowledge, for example, with supervised fine tuning, or adding incremental knowledge with prompt learning, or even having reinforced learning from human feedback. So you can have your own version of a model that then you can complement with the enterprise data. So you can then start increasing and applying more intelligence into your AI. There are so many different techniques of model customizations. The columns in this table represent a set of techniques referred to as different techniques of how you can customize a model. For example, in the domain specific models, like with supervised fine-tuning the model with domain specific data to incorporate the relevant knowledge is something that will improve the intelligence of the model and will reduce its feedback, its size when it comes into customization. Everyone is familiar with prompt engineering. Prompt engineering is great for prototypes. It's great for quick use cases, but the more data that you will have and the more prompts and the more interactions with your users, basically will slow the performance of the application and with the throughput of your model. And then eventually, if you are using a managed generative AI service, like maybe OpenAI or ChatGPT or Gemini and so on, you will start seeing a growing increase in the cost because you're relying on prompt engineering. Prompt learning is an interesting approach and an interesting technique that can help you to reduce the impact and the results and the consequences of the prompt engineering and add an incremental knowledge through it. With only few hundred examples, you can gradually train the model with additional knowledge through this technique. And this is one of the best ways that can allow you to expand the model's understanding of newer concepts. Keep in mind, your end users will keep challenging your models. So you need to keep capturing those so you can increase your model's understanding of the newer concepts and information over time. Reinforcement learning from human feedback is definitely recommended for continuous knowledge. Utilizing the human feedback to train the model further and customize it further to improve its performance This will reinforce the positive behavior and it will refine the model's responses based on the user inputs. All of those different techniques are available for you in the Nemo customizer. In the evolving landscape of AI, reinforcement learning with human feedback stands as the beacon of progress, allowing us to refine the AI models to unprecedented accuracies and reliabilities. So, this is one of the techniques that we are supporting heavily with so many different ways and different policies that can help you maintain consistency and also increase the accuracy of your models. All of this is contained within a single module called Nemo Customizer. Then comes a very, very important phase that a lot of people skip. It's the model evaluation. After doing your model customization or model training or model augmentation, what are the ways that you can check how well is my model doing? Enterprises today have the option of a huge number of large language models to choose from, and it's critical to be able to choose the best LLM for your use case, and this needs evaluation. And Nemo Evaluator is the one stop shop for evaluation needs as part of the Nemo ecosystem. It provides you out of the box with an automated evaluation of your models and even the fine tuned models, whether it's traditional foundation models like OpenAI ones and so on, or your custom version of them against academic benchmarks, against custom benchmarks that you can define yourself. And you can even set up Nemo Evaluator to act as an LLM, as a judge in an online approach. It's basically a platform for human evaluation and scoring. And you can give this and you can use it as a microservice that will take in the model and the data set, and it would output the evaluation results. Nemo Evaluator supports both online and offline evaluation. Offline evaluation basically will let you prepare the evaluation data set, run the assessments at specific times to determine whether the model or the application is performing as expected and to ensure there are no regressions. The online evaluation is even more interesting. It allows you to integrate the Nemo Evaluator directly into your application and assess the model responses before displaying them to the user. And this is one of the features that you can use the LLM as a judge. And you can do that even on your retrieval and RAG metrics. So this is being applied across the board. And you can imagine that this is becoming very, very important, especially when you are building agentic AI. Agentic AI and generative AI application development is becoming increasingly evaluation driven. If you don't have an evaluation framework, then you are always at risk. For every update at the component level, developers must evaluate changes both at the component and at the overall system level. For example, AI agents use an LLM to generate a plan. They are using tools and or maybe retrieving information from other systems and invoking other LLMs to respond to user queries, or maybe sometimes even generating code. Developers need to evaluate the AI agents at the system level, which means whether the agents are effectively solving what the user is asking for. But at the component level, developers might evaluate also the following. For example, whether the right tools are being called, or maybe are they being called with the right parameters, or whether the responses from the other LLMs are also as expected, whether the retrieval pipeline responses are accurate, whether the embeddings and re-ranking models are suitable for the specific use case. To simply put this, evaluation is very, very important for anyone building agentic AI or generative AI application. And I can tell you, this is one of the biggest and most important steps that a lot of application developers are actually missing. So we have also provided Nemo Evaluator as a microservice to simplify the end-to-end evaluation of generative AI applications, including RAG implementations and agentic AI with an easy-to-use APIs. Providing this with an LLM as a judge capability, along with a comprehensive suite of benchmarks and metrics for a wide range of custom tasks and domains, including reasoning, coding, and instruction following, you can seamlessly integrate the Nemo evaluator into your CI CD pipeline for the offline approach to build this data flywheel in consistency with continuous evaluation. And you can also have it as a cloud, as an online version that can evaluate the performance, evaluate the responses before they are being passed to the agent and to the end user. The evaluator is a flexible cloud native architecture. It allows you to deploy it anywhere and wherever your data resides, whether on premise or in private cloud or across multiple public clouds. And as you can see in the chart on the right, the evaluator allows developers to streamline the evaluation of custom models to reduce this, to reduce the processes from 21 steps with alternative open source libraries to just 5 steps. And also scaling with an LLM as a judge, you need to make sure that the throughput is as fast as possible. And this is also what Nemo is offering. There's a lot of ways that you can integrate Nemo evaluator as an LLM as a judge, along with complementing with evaluation metrics. You can use it as an offline mode. And you can evaluate whether custom models are accurate for various use cases as part of your CI/CD pipelines. After you've done and you have implemented your model evaluation process, it's very, very important now to start talking about guardrails. Nemo guardrails will keep your generative AI application and models on track. Nemo guardrails is an open source project that you can use, and it will provide you with whatever that is needed to protect your LLM and your generative AI application from preventing executing malicious codes, handing power to third-party apps, jailbreak detection, jailbreak prevention, topic enforcement. Nemo guardrails will have you covered. Nemo guardrails is an orchestration platform for safeguarding AI at scale. You can orchestrate multiple rails, we call them, or guardrails, across different applications in a scalable and modular framework. You can use the smart defaults that we have added, and you can also extend them, leveraging a number of integrations that we support across the ecosystem. We also have we have a built-in auditing and analytics that you can continuously monitor and adjust the rails for better protection over time. And it's available as an open source project, as I said, for the community innovation and integration. And it's also available as an enterprise grade microservice that you can run literally anywhere, on-prem or hybrid or in multi-cloud. You can build and own your customized guardrails to implement content filters, to prevent harmful language or system exploits or prompt manipulation attempts, to enforce or restrict topics using simple, brief language instructions, and also to sanitize the AI generated content by removing personal and sensitive information. You have a PII detection module in it, and also mitigate the AI hallucination by evaluating response relevance and factual grounding in your own knowledge base. And also, you have jailbreak detection that you can leverage. In short, Nemo Guardrails will provide you with the real time and with the runtime for topical enforcement, for safety, and for security. And you can use it anywhere. And as you can see, you can use it with any open source model that is available as a microservice within the NVIDIA ecosystem, but you can also use it with any third party LLM. This will be your one stop shop to make sure that your generative AI application is safe. Great. Second step is model augmentation. And model augmentation is different from model customization. LLMs, in their raw nature, are very, very powerful tools, but they are not accurate. They're designed to be generative, right? To be creative, to generate tokens. Without a connection to your and to, like to an enterprise data sources or to an actual data source that you want to bound them to, LLMs cannot provide you with highly accurate information because they lack the proprietary knowledge. There is always a risk of outdated information. And even if the model is connected to the internet, you don't have visibility on which sources it's looking at. And this is also resulting in a lot of hallucination. And therefore, retrieval augmented generation techniques have been introduced. Enterprises must piece together solutions from open source community to update and maintain them. And this works in a way, but is very, very complex. And each approach has its own pros and cons. And there is a lot of different complexities in every single step in here. RAG application depends on high quality text embeddings. And this is one of the best and the most important things that a lot of developers ignore. Depending on the quality of your embeddings, basically this would determine how good your RAG application is. And this is where we have made a lot of innovation. We have and we are providing you with an optimized RAG implementation along with the best and the reference architecture of how it should be built. The Nemo Retriever, which is the another module within the Nemo framework, comes with multiple models that can help you. The Nemo Retriever, it's a collection of generative AI microservices that are designed to help you connect custom models to their diverse business data, ultimately delivering highly accurate responses. It's a key component in building RAG implementations and applications to enable your systems to access relevant and context-aware information. First, it's built in microservice architecture, which means it will be natively scalable and flexible with various use cases that you can run either in standalone or at scale on your Kubernetes cluster. It provides and supports multimodal extraction. It supports the extraction of various data types, including text, tables, images, building context-aware AI applications, because it also leverages the data curator, and it has enhanced and improved embedding and re-ranking models. This would allow you for efficient and accurate retrieval information. And it also provides great multilingual support. It's designed to handle multiple languages, making it suitable for global applications. And also it supports long context supports. It supports large volumes of documents, including long form content without compromising accuracy. And it's designed to prioritize data privacy, ensuring secure handling of sensitive information. The results are twice the accuracy, significantly faster embeddings, and optimized inference engine. all with a world-class models and support. Our observations when customers are using Nemo Retriever embeddings and re-ranking models is massive. Between an increase in 30 by 35% in fewer incorrect answers, 3 times improve the throughput for your embeddings. This means that preparing the data for your LLM becomes way faster. And then we are also faster in re-ranking throughput, which means that you can re-rank your results, which will massively impact how good your models is responding with on top of this data, as well as also how fast this will happen. When it comes into cloud deployments, RAG implementations massively rely on managed services, like maybe storage or search services, which drives the bill really, really high without knowing why. These open source models that we are making can improve your data storage efficiency by 35x. This will provide you with a lot of savings just because you improved your re-ranking, your embedding process. Vector search is an essential part of RAG implementations. We created QVS. QVS is another open source framework for vector search, and working with Nemo Retriever would enable massive scale with acceleration. This means that you can have from 5x to 7x improved throughput on your vector search after you do your embeddings. With this, you can get and be sure that you will have 50% fewer incorrect answers, less hallucination, 15 times improved multimodal extraction throughput. This means that regardless how your documents and unstructured data set is, you will always have a better performance without even going into the data curation phase. And you will have around 35 times improved data storage efficiency will massively impact your cost optimization direction. Now, let's talk about inference. With the growth of large models and with the growth of the different types of models that you will have between generative AI, our classical deep learning and machine learning, you need to have also a platform that you can rely on for inference, for online deployments, for multifunctional, and to support multiple different types of use cases. And achieving this at scale is very, very important. There is a lot of challenges when it comes into this. How I can have an easy to use inference engine or a platform that can support multiple frameworks, can support different types of queries, whether I want to serve my models in real time or in batch or in streaming, and how can I have visibility on the infrastructure and the deployment. There is a lot of challenges when it comes into this. And for that, I would like to introduce you to Triton. NVIDIA Triton is an inference engine, an inference server that is addressing generative AI related use cases. It works and it supports the standardized inference platforms, the different backends. It works with any model that you have built, whether you're using TensorFlow or PyTorch or even scikit-learn XGBoost or ONNX runtime, Triton would support you. Triton provides integration endpoints over HTTP and HTTPS, gRPC, as well as also C++ communication. And Triton is also platform agnostic. It runs on CPU and it runs on GPU. It runs in standalone and in clusters. It runs on Kubernetes, and you can even push it to run on Jetson GPUs. Those are like the edge GPUs. It runs on Windows and ARM as well. And it supports the different types of queries, whether real time or batch or streaming or ensembles. And it provides you with a lot of LLM ops and AI ops capabilities, concurrent model execution, load balancing, increasing the throughput for specific models, utilization metrics that can help you to lower the costs, and it provides you with dynamic batches, which would maximize the throughput under the latency constraints. As I said, Triton would run and would support a lot of ways of modulation, whether running in standalone or in Kubernetes to scale, integration with Prometheus for the metrics, as well as also to become part of your ML ops lifecycle because it provides you with a lot of interesting telemetry that can help you maintain your generative AI application in a better way. And Triton is not an alien project. It's being adopted actually as we speak by the leaders in the market and in the industry. So whether you are building for generative AI or for traditional machine learning, Triton is there for you. However, there is a new generation of larger models. Those models are becoming hundreds of billions of parameters. They are providing longer thinking times, and they are coming with much larger context of millions of inputs of tokens. And this requires a different platform, a platform that is designed for the reasoning era. And this is where and why we open sourced NVIDIA Dynamo. NVIDIA Dynamo is the next generation of inference engines for reasoning models at scale. Dynamo comes, it builds on top of Triton. It's building on its success, and it's offering a new modular architecture that is designed to serve generative AI models in multi-node distributed environments. Dynamo enables seamless scaling of inference workloads across GPU nodes and dynamic GPU worker allocation to efficiently respond to fluctuating user demand and handle traffic bottlenecks in multimodal AI pipelines. Dynamo supports all of the major LLM frameworks, supports VLLM, supports SGLang, and it incorporates state-of-the-art LLM inference serving optimization techniques like disaggregated serving, which means that Dynamo understands the model and understands which GPUs are best to operate in which phase and how to distribute the KV cache across multiple nodes to speed up the token throughput. For example, when serving the open source DeepSeek R1 model on NVIDIA GB200 with Dynamo, with disaggregated serving, we increase the number of requests and token throughput by 30x. We went from 800 tokens per second to, I believe, 26,000 tokens per second. NVIDIA Dynamo can double the throughput performance when serving compared to other infrastructures. Traditionally, serving LLMs had some performance limitations because of the collocation of the prefill and the decoding phase because of transformer architecture on the same GPU. This was basically leading into inefficient resource utilization. For example, in the prefill phase, the GPU compute cores are working in parallel to generate the contextual understanding of the user request, making it compute bound and compute intensive. But in the decoding phase, which is this phase, the memory resources are what is being fully utilized to generate the output tokens, making it memory bound. Combining the two phases with their distinct resource demands on a single GPU or on a GPU node, it was resulting in an efficient resource use. This issue was basically more pronounced in long input sequences where the GPU resources are underutilized during the prefill phase. We have solved this with a technique that is called disaggregated serving that we implemented in Dynamo. We are separating the prefill and the decoding phases to allow each to be optimized independently. So when a user is submitting a request to a model, it goes through two distinct computational phases, the prefill and the decoding phase. Each phase is using the GPU compute resources differently. And during the prefill phase, for example, the system will process the user's input to compute the contextual understanding of the request and generate the first output token. The latency of this phase is measured by the time to the first token. In the decoding phase, the system will generate all of the responses remaining tokens individually, updating the contextual understanding from the prefill phase with each new token. This phase is measured with what we call the inter-token latency. There's a lot of capabilities that we have added in Dynamo. It's not just disaggregated allocation. Distributed inference serving. You can seamlessly scale the LLM from just one single GPU to thousands of GPU if you need. The GPU planning and scheduling. We will meet the changing demands in patterns without over or under provisioning of resources. We have a smart request routers. We will free up the GPU resources by reducing recomputations for similar requests because we are also able to preserve the GPU memory by offloading the context, which is the KV cache, to cheaper storage. And we can also distribute the KV cache. And that's why we're able to accelerate the GPU to GPU communication as well. The performance optimization and the time to first token and the average request token latency is massively reduced. And actually, although Dynamo is quite fresh and quite new, it's only several months, I think it's about now 7 months old, it's already being used by our partners, and you can also use it. You can use it to serve reasoning models. You can use it because it's designed for agentic AI and it's used and is designed for distributed inference. And you can use it for scalable code generation use cases as well. Dynamo is available also as an inference microservice. Just to complement the ecosystem, NVIDIA is also offering optimization platforms that can help you to optimize models. TensorRT allows you to optimize any AI model regardless how you created it for high throughput and low latency inference on the GPUs. It doesn't matter how you optimize the model, how you optimize your neural network, even if you built it with TensorFlow or whatever, you can recompile it with TensorRT and you would get an optimized version of the model. NVIDIA Tau toolkit would allow you to apply transfer learning to adapt your own models or pre-trained models for computer vision. So instead of reinventing the wheel or applying transfer learning from scratch, you can use Tau for that. And again, you can use Triton or Dynamo inference servers depending on your demand and your needs. Along the journey, I have mentioned Nemotron. Nemotron is the new family of models that we have created. And under Nemotron, there is two variations. The Llama Nemotron, which is the language models, and Cosmos Nemotron, which is the VLM, the vision language models. Both of those types of the Nemotron family models come in three sizes: nano and super and ultra, like small and medium and large. These models are state of the art models in so many different ways. First, they are fully open source. And when we say they are open source, it's not just the model and the model weights, it's also the data sets, and it's also the data curation pipelines and the model building recipe. We are opening this to the ecosystem. These models have gone through all of the famous performance and accuracy benchmarks, and it has scored the best. It's the highest efficiency, and it's enterprise ready, and it's available also as a container. And you can turn on and off reasoning. You can use it as a reasoning model, or you can use it as just a traditional simple language model. Cosmos Nemotron is considered to be the first phase of the new frontier models that we are creating, the next generation after the traditional large models. We're calling it the World Foundation models. These are models that are trained with physics, and they are trained for the time and era of physical AI. I can give you an example of why this is very, very important. Generative AI brings computer vision and physical AI together. And real world data is very, very costly to capture. And physical testing is very dangerous and very, very expensive. And that's why we created the WFM, World Foundation Models. It provides you with pre training demand technical skills and state of the art model designs, robust data strategy and infrastructure. The accuracy of the models for physical AI depend always on the quality of the training data, which we have taken care of carefully. We carefully curated the data captures with hand motions, object manipulation, spatial awareness, navigation, dynamic visual transitions to empower those World Foundation models to perceive and understand the physical world like humans. Those models understand physics, understand the physical world to deliver outputs that simulate real world physical and visual behaviors. We created three versions, three different types of models within Cosmos. The first one is Cosmos Predict. Cosmos Predict generates video sequences or world states from text or video or image or a pair of them. Developers can post train this model to build specialized models and policy models to guide robots or to generate synthetic data to train your models for use cases that you want to capture. Cosmos Transfer will convert the structured inputs like LiDAR images, dashcam footage, 3D maps into photorealistic, physics accurate worlds. Developers can use Omniverse, which is our digital twin application framework and simulation framework, to build precise simulations. We call it the ground truths, where you can train and scale models across different weathers, different lighting, terrain, and all of these different conditions with Cosmos Transfer. And lastly, Cosmos Reasoning. This is a fully customizable multi-model reasoning model for physical AI. It processes visual input, runs a chain of thought to reason through all physical interaction scenarios, and it delivers the best response to the ask using reinforced learning. Developers can use it out of the box, or you can post train it and customize it to build more sophisticated and complex AI models that can take action after reasoning to advanced embodied and physical AI. You can see that Cosmos Predict can really diversify the AI training data with synthetic data. With just a traditional and simple video clip, you can generate high quality video clip with synthetic data that can you be used to train your models in a more generalized form. That's the same with Cosmos Transfer. It generates high fidelity world scenes from structured input like LiDAR images, dash cams, 3D maps to ensure precise spatial alignment and scene composition. These models preserve the pre-trained knowledge, enabling the structured and consistent outputs, and it utilizes the spatial temporal control maps to dynamically align the synthetic and real world representation together, enabling the fine grained control over scene composition. As you can see, the output is photorealistic video sequences with controlled layouts and object placement and motion, which is very suitable to generate and scale the synthetic data to generalize your data sets. And lastly, Cosmos reasoning. Just a quick overview on vision language models or vision large models. They are a type of multimodal models that combine vision encoders with a large language model to understand and process both images and text simultaneously. Cosmos can understand the scene or what is shown in the video, but there is always something missing in traditional VLMs. They couldn't understand or reason through the long tail of diverse, unseen scenarios. And that's why we released Cosmos Reasoning as an open, commercial ready reasoning VLM, vision language model that thinks like humans, using prior knowledge with physics understanding and common sense. Cosmos Reasoning can do things non-reasoning VLMs couldn't before, like, for example, solving multi-step tasks, handle ambiguous and new experiences, and it's a state-of-the-art model, topping the leaderboard, and it's open and fully customizable for developers. We have a 7 billion parameter size that makes it perfect for physical AI edge and robotics deployment, and it's good for any robot, humanoids, autonomous vehicles, factories, and cities. Those family of models are now being downloaded more than 1 million times on Hugging Face, and it's scoring at the top of the leaderboard of benchmarks. And we have created not only the models, but we are also opening and providing Cosmos guardrails, similar to the Nemo guardrails for the LLMs to protect the models. We also released Cosmos Guardrails, which is a dedicated neural network for improving the safety by filtering the input prompts and blocking the unsafe outputs. Developers should add guardrail models before deploying any world models and to ensure the generation are always safe and consistent. So all of this is available for you as what we call the NIMs, NVIDIA Inference Microservices. We have simplified the NIM, the model deployment and model acceleration. We have also optimized the models within. You would find all of the open source community models available as NIMs, as NVIDIA Inference Microservices, with a significant improved and optimized throughput. It's production ready, it's secure, and it's scalable out of the box. And you can deploy it anywhere with security and control. We optimize the models with TensorRT, so you don't have to do that yourself. If you want to do it, we strongly recommend that you use TensorRT. We are providing standard APIs, so you can treat all of the LLM models like Lego blocks that you can pull and push as you need and as you see fit. We have also optimized the inference engine, and we have making this as cloud native. You don't have to be tightly coupled to any cloud. And you have the enterprise management attached as well and made available for you in every NIM. NIMs are not available only for LLMs. We have made them available across the whole AI stack and ecosystem, from reasoning, from text, visual, speech, and even for domain specific models like healthcare and computer vision, as well as also a lot of other aspects of the AI landscape. Whenever you are building anything in AI, even for an MVP or a POC, you would take around five, between 5 weeks to 5 months to get something done. With the introduction of NIMs, you can get up and running in a matter of days. You can just deploy with a Docker run command, and you can start integrating and running and building against it instantaneously. Building AI agents requires multimodality and tools, and the NIMs would improve you with great flexibility and also great token throughput, which means that on the same infrastructure, you don't have to scale because, and unless you really need to, because our models are providing massive token throughput in every step. And we're not just providing you with those Lego blocks. We are providing you with end-to-end use cases that you can start with. We call them the NVIDIA blueprints. You can see all of those blueprints if you go to build.nvidia.com. The blueprints are providing you with the reference code implementation for the all end-to-end use case. For example, if you want to apply and create a visual AI agent that will do video search and summarization and questioning and answering, and if you want to do that at scale, see if we can run this video. If you want to do that from scratch, it will take you 3 months at least to implement this, to integrate with the video feed, to do the chunking, to do the pre-processing, the image captioning, and to introduce the RAG approach, to do the navigation and to do the reasoning. The architecture is very, very complex, as you can see in here. The ingestion pipeline is complex enough, and the retrieval pipeline is even more complex. We're providing you all of this, the architecture, as well as also the reference implementation, and it's ready available. You can pull it from our GitHub repo and you can deploy it in a matter of few days rather than taking months to implement. Building agents is basically where everyone is busy with now. AI agents are growing. The ecosystem will turn a $1 trillion enterprise software industry from tools designed for your workforce into a workforce to aid the employees. And instead of manually programming every line of code and compiling applications for CPUs, you can simply use and prompt LLMs to write the applications for you. There is a lot of potentials coming with AI agents. But before we dive into what we are making and what we are doing for AI agents to help them become better, let's learn and let's level set on how AI agents are working. Thinking. AI agents are operating using a cycle of perception, reasoning, planning, and actioning. They process inputs like user queries or environmental data and use advanced models like, for example, LLMs to analyze information, identify the patterns, and decide on the best course of action. Reasoning can involve step by step logic, where the agent thinks after each action and tool use, updating its plan iteratively. Prompting, it's the interaction typically begins with user prompts, which provides the agent with a goal or a question to address. And then the tool usage, which is usually dynamic. The agent decides which tools to use based on the task requirements and the information available at each step. And then the computer use, where basically the agents would leverage the computer resources to process the data, execute a code, interact with the digital environments, and they may access files, run scripts, control other software systems, and so on. And then you need the memory. This is very, very crucial for context retention, for learning, for personalization. The short term memory would enable the agents to maintain the context within a single session or task, and the long-term memory would enable the agents to recall information across sessions, for example, like the user preferences, historical data, previous interactions, supporting the learning and improved personalization process, and so on. And then you have the interaction between with other agents. As you can imagine, building agentic systems requires a lot of things. It's very, very complex. There is architectural complexity, there is repeatability, there is code reuse, there is performance, the user and AI interaction, the trust between humans and agents and between agents and each other. Can an agent trust another agent? The learning and adaptation, the safety and security and the privacy, as well as also the enterprise readiness. There is a lot of complexity when it comes into building agentic systems. Through Nemo framework, you have the end-to-end structured framework that you can use and standardize the creation of every agent. Using the NIMs, you will have the standardized and secure models that your agents can start using. And with the blueprints, you start having the foundational elements of the agents. You have blueprints for research assistance, for customer service, for security, software security, for CI/CD, and for code generation, etc., etc. And we spoke about the building blocks of agentic. Nemo Retriever to ensure that the agent will have faster data extraction and less hallucination. We spoke about Llama Nemotron as number one small model for reasoning, which is designed for agentic AI. And then we are providing you with the Agent Intelligence Toolkit. The toolkit is an open source library that enables the developers to build the AI agents with advanced querying capabilities so you can deliver insightful analysis. You can build the agents how you want. The toolkit will enable you to more easily connect the agents and build with different, that basically connect those agents that are built with the different frameworks, but it will provide you with the evaluation framework that you can evaluate each agent individually and also with interconnection, and also identify where the bottlenecks are. You can imagine the AI agents like a digital workforce that will work alongside us. And therefore, the agent toolkit will be the framework to guide those AI agents in their work. It will provide you with three main pillars: profiling and optimization. This means that you will get metrics and tools for the AI agents to become more productive. You will be able to measure the performance and the behavior of your AI agent. We're not talking about the LLM, we're talking about the agent itself that you created with one of the traditional and most kind of like famous platforms and frameworks. You will have the evaluation and observability framework. This is basically like the AI agent performance review. The Nemo Agentic AI Toolkit will measure the performance will evaluate, and will provide you with an observability layout to identify the areas for improvement and where those AI agents are lacking. And also the collaboration. The toolkit enables agents to connect with each other and with tools requires to do their work. And it provides those tools via a reusable tools and agent registry that is accessible to anyone in the organization. It includes a configuration builder to automate the deployment of the agents. With this open source toolkit, developers can build agentic systems faster, save time by using existing tools and frameworks, and you can reduce the infrastructure cost while improving the performance of your agentic system, which will also ensure that the system is providing the most accuracy responses. Like we are hiring and nurturing employees, companies will also build digital workforce that is trained on the company's specific methods. With Nemo as a framework, from curation, customization, evaluation, and guardrails on learning, you will be able to build end-to-end data AI flywheel so that the AI agents can continuously learn and improve as they work. We are also providing a blueprint, an end-to-end architecture with a reference implementation that you can use out of the box. We call it the AIQ blueprint or IQ blueprint. It's an open source blueprint for connecting the AI agents and the data and the tools to build agentic systems that address many use cases. It's available also on build.nvidia.com. This is basically our blueprint, our playground, where you can test the blueprint and you can play with it before downloading it. The blueprint is using a reasoning model and the Nemo retriever extraction and retrieval microservice to provide highly accurate, fast responses. And with the blueprint, you will be able to experience the AI agent for research and reporting using available healthcare and financial data sets. There's a lot of resources on our developer programs and on our GitHub. So feel free to create your accounts on the developer programs. When you do that, and when you go to build.nvidia.com, you'll be able to also integrate your applications with it. We usually give between 5,000 to 10,000 tokens for free. So make sure that you use that also before you download the code. And now we can open the session for questions.
Ahmed, I think we have several questions in the chat box since participants can't open their mic, so we can refer to the chat box and answer the question if you'd like to. So we have a
On the
question, for
chat, okay.
example, from Hamza. Shall I choose one RN, or I can do my search then choose, for example?
I'm not sure I understand the question.
Okay, we have another question. Uh, just one. 1 second. Yes, got lost. This is a question from Mark. What is the difference between the Nemotron models and Cosmos models?
So Nemotron is the greater family of the models. And under that, we have Llama Nemotron, which basically we distilled from Llama and retrained the model with more data sets and added more capabilities on it. And we enabled basically reasoning to be turned on and off. So this is basically the language model with reasoning capability that you can use for agentic AI. And Cosmos is for computer vision and physical AI. So Cosmos is a new family of models trained and built with Nemo framework. That's why it's called Nemotron. And it's designed for computer vision and physical AI. This is basically the next generation of what we call the world foundation models. Second question.
Yes. This is a question from Ahmed. When is the deadline of choosing one of the courses, for example?
So I believe the courses will be made available for, I think, until the end of the year. So I strongly recommend that you register in one of those courses as soon as possible. Once you register in a course, you have, I think, 3 months or maybe 6 months before the course expires. So you need to finish it within, I think, 3 months. I do see a question from Amin. Nemo Curator works with specific data types, not just anything. Nemo Curator supports a lot of data sets and a lot of different types of data types. So it works with text, it works with audio, it works with images, as well as also with video, as I have explained. So Sundos is asking if Nemo is providing tools to evaluate the model's performance. I believe I have answered this. Yes, you do have Nemo Evaluator, which can be used on offline and an online approach. Yeah, sorry, Daniel and team and everyone. I cannot really give you a break because, yeah, I already gave the disclaimer. The session is very long, but you can watch it with a recording. Any other
Exactly.
questions that you see?
Excuse me, Ahmed?
Yeah, I do see a question from Mark. Can I use Nemo for my personal project? Absolutely. Nemo is available as an open source framework and projects. So an independent module. So you can use each module independently. You don't have to use the whole framework. Like if you are interested only in data curation, you can use it. If you are interested in guardrails and so on, you can use it. Not everything in the ecosystem requires GPU, but of course, everything is designed to work on the GPUs. Um, so yeah, but of course, there will be things that cannot work without the GPUs. Mark is also asking if Nemo is designed for LLMs. Yes, Nemo is designed for generative AI in general, multimodality and generative AI in general. It's a framework to maintain and ensure basically what we call as LLM ops with model consistency. And you can use it with the different modules independently in your AI application. If you have a computer vision or CNN like convolution problem, I would recommend that you look into Metropolis as the umbrella of a lot of models in computer vision, or you can look at Tau. NVIDIA Tau would help you to apply transfer learning in computer vision. And Tau is also available as open source. And for the audience, don't forget to look into TensorRT. If you are a data scientist and you created a model in some way with some application and framework, you can optimize this model with TensorRT for inference. Uh, okay, I think we answered that question.
Uh, mm, Ahmed, we have a lot of questions actually, and I can see that several questions are repeated. So what I suggest is to, for example, open the the WhatsApp group since we are pressed a little bit by time, we can open the WhatsApp group, and participants can share their questions right there if you'd like to.
I know that
Or
would
for
be very,
example,
very
they
hard
can
for me
send
to
you
track.
the question via your LinkedIn.
It will also be very difficult to do. I would recommend that you can use actually the our GitHub like ecosystem is very, very active. I would
Yes,
strongly recommend that you can use the GitHub comments, for example,
yes,
and our documentation is very, very well detailed as well. So basically, my
perfect.
objective from today is to walk you through the ecosystem end to end.
Yes,
So just to summarize, we covered the Nemo framework with all of their
yeah,
modules. And then we also cover the state of the art models, the Nemotron family of models, and also the agentic AI. So if you just type NVIDIA Nemo or NVIDIA Agentic or NVIDIA Nemotron, you will find a lot of the documentation. And if you go through the developer program, you will learn a lot as well.
yes. Ahmed, could you please share with us the GitHub link, please?
Actually, we have many GitHub repos. So I would strongly recommend also just searching on the internet on NVIDIA GitHub, and you will see a
NVIDIA
lot of
GitHub. Let
these.
me just
Yeah. So
help.
NVIDIA Nemo GitHub, and you will see a lot of GitHub repos that can guide you.
Okay, I will share it right here. And guys, you can, yes, this one. I will share it also on our WhatsApp group. So quickly, so participants, second. So guys, I will be sharing this
Okay.
link via the WhatsApp group, so you can all share your questions and write them down. Your questions. Okay, it was great. It was a really great masterclass, Ahmed. It was a real pleasure having you with us. I think this is the second masterclass that you animate, right?
I guess so. Yes. It's always a
Yes,
pleasure working
yes. This
and
is the second
collaborating
time
with my code.
that I
Thank you
have
for
the chance
having me.
to have you.
Thank you so much. Have a great day.
Thank you so much, Ahmed. So,
Thank
guys,
you.
thank you for being part of this masterclass. It was a real pleasure having you all. I will share with you the WhatsApp link right here so you can join the WhatsApp group. I will be sharing the recording of the masterclass in the WhatsApp group as well. So, 1 second, and I will share the Go My Code website here as well. It will be helpful for you to discover the different services and tracks that we are offering. We offer different trainings, and we implemented AI in all the tracks that we offer in digital marketing, in graphic design, and the web development, etc. So it will be a real pleasure for us to have you all visiting our website. Guys, 1 second, I will be sharing with you the WhatsApp group. 1 second. Yes, and this is the WhatsApp group. So yes, let me just share my screen here just to have the tour about our Go My Code website so quickly. So this is the GitHub, the NVIDIA GitHub that I shared with you guys. You can all of the GitHubs are public, of course, and you can join these GitHubs to share with you, share with the NVIDIA experts your thoughts and questions. So guys, this is the website of Gomeka Tunisia. So here I will change it into English, of course. So here you can find all the courses that Go My Code offers. Here you can find all the hacker spaces that we are implemented in. Here you can find the Go My Code School of Technology, and this is an extra training. It's a different and specific training for all the Go My Coders. It is like a master degree in the web development in partnership with an international university named Wolf. This is the online hackerspace or the online courses, and we have Go My Code Business. So, for example, if you want to contact us or discover the trainings for sure, the new trainings, you can find them right here. Guys, you can share. You can see my screen, right? Yes, perfect, perfect. That's perfect. Okay, so these are the different trainings that we offer and the newest training that we offer. For example, we have the deep learning NVIDIA certified. Since we are an exclusive partner of NVIDIA, we offer trainings that are certified NVIDIA. The deep learning training is one of them. It is an advanced course, and you can learn more about it when you click learn more on our website gomacode.com. We have also the build your product with AI tools. It's so interesting for those who want to learn more about AI and how to implement AI in different fields, and specifically how to use AI in a very specific model or a very specific product. The generative AI and LLMs, of course, with the certification of NVIDIA, is one of the advanced courses that you can learn more about. Of course, if you want to contact us, you can just go below the page and enter your information right here. You write down your first name, last name, your phone number, your email address. You select the hackerspace that you wish join and the product that you wish learn, then you submit. Later on, one of the consultant educational consultant will contact you back and will explain to you more about the products and the different trainings that we offer. Guys, AI is a very and a highly recommended skill for each person on earth. So guys, if you want to learn more about AI, if you want to be certified NVIDIA, you should definitely join our community and learn more about the courses of GoMyCode. I will leave down here the GoMyCode website so you can visit it and learn more about the courses that we offer. So this is the GoMyCode website. You can visit it. You can learn more about the tracks that we offer, and do not miss. One second. Do not miss the upcoming master classes that we offer for free, and of course the products that we offer at GoMyCode. So guys, it was a real pleasure having you all in this masterclass. I hope to see you soon in the upcoming masterclasses. Keep it up. Keep We will keep updating you about the courses, the products, and the different masterclasses that we offer. And we hope that we see you very soon. Thank you so much. Just for your info, the recording of the masterclass will be sent via the WhatsApp group. Thank you. Can you share of course, as I said, yeah, the recording of this masterclass will be sent via the WhatsApp group. To answer the last question, there is no certificate of attendance for this masterclass, but I am definitely sure that you learned very more things than ever in this masterclass. So thank you so much, guys. See you in the upcoming masterclasses. Have a good night. See you soon.